All right, here's our second video for section 5.1. We just got done talking about GCF, greatest common factor. We're going to continue talking about factoring. Before we get into more techniques of factoring, what I always tell my students to do anytime the question asks us to factor is follow 7 different steps. If you can follow these 7 steps, that'll guide you every single time you're doing a factoring question. So here we go. Anytime it asks you to factor, the first thing you should be doing is writing your problem in order. What I mean by that, it should go from your highest exponent to your lowest in standard form. And if there's an equal to sign, you should put everything over to the same side of your equal to sign first and set it equal to 0. So put it in order and move everything to the same side. Step number 2. Always, always, always look for a GCF first before you do any other type of factoring. Look for a greatest common factor. Factor that out first, and then you can continue on with the next few steps. From here, what you have to do is figure out now if you have 2 terms in your problem, 3 terms in your problem, or 4 terms in your problem. And depending on how many terms you have will depend on what step you do next. If there are 2 terms in your problem, you're either going to factor with a difference of squares, or you're going to factor with a sum or difference of cubes. I know that doesn't make sense now. We'll talk about those techniques in a later section. If there are 3 terms in your problem, then you're either going to try to factor by basic factoring, or you're going to factor using a technique I like to use called bottoms up. If there are 4 terms, 1, 2, 3, 4 pieces separated by a plus or minus sign, then you're going to factor using a technique we called grouping. Okay, now that we have those steps, I want you to follow those steps every single time you do a factoring question. Let's do some. Let's first talk about factoring out a GCF. We talked about greatest common factor in the last video, and so anytime I give you a polynomial and I ask you to factor, remember the first step is to put it in order, and the second step is to look for that GCF. So you're going to look for the greatest common factor of each term. You're going to write that out in front, and then you're going to leave some parentheses. You're going to divide each term in your polynomial by that GCF and fill in those parentheses with what I call the leftovers. And then you can always check your answer by distributing or multiplying back through. Let me show you some examples. In example 2, it's going to ask us to factor. So on example number 2a, number 1, is it in order from your highest exponent to your lowest? It looks like it, right? Step number 2 is we're going to look for a GCF, a greatest common factor of each term. So let's start with the numbers. What number, greatest number, can divide into 8 and 12 at the same time equally? I got 4. So what we're going to do is we're going to go through and we're going to divide each term by 4, and we're going to leave our leftovers in the parentheses. So 8 divided by 4 is 2, and you notice that I have an a still next to it, minus 12 divided by 4 is 3. Now, if there were multiple variables in each term, I would also look to see if I can GCF out a variable. But since the first term is the only term that has an a, I can't factor out an a from each term. That's why I left it in the leftovers. So my GCF here is just a 4. I can take out a 4, and then I have left over 2a minus 3. Now you can always double check that answer is correct by simply multiplying back through. So what's 4 times 2a? 8a, right? And what's 4 times negative 3? Negative 12. And that should always get you back to where you started, so you know you got the correct answer. Let's do some more. Look at b. I have 2 terms. It looks like it's in order, right? The highest exponent to the lowest. Now let's look for a GCF. So what number, highest number, can I divide equally into 24 and 30? You might need to write them out off to the side, and that's okay. Find the biggest number that you can divide into there equally. To me, it looks like maybe a 6, right? So if I take out 6 from each one, I'm going to divide each term by 6. But now look at this one. This one also has variables. And let's see if there's a greatest common factor that I can take out of x to the 5th and x squared. What's the biggest amount of x's they have in common? Well, to me, it looks like an x squared. So I'm going to go through and I'm going to divide each term by the GCF of a 6x squared. I'm going to put my GCF in the front of my parentheses, and then I'm going to put my leftovers inside after I'm done dividing. What's 6 divided by 24? 4. If I have x to the 5th and I divide it by x squared, remember your exponent rules, when you divide you really subtract the exponent, so you should have x cubed left. plus 30 divided by 6 is 5, and x squared divided by x squared, those x's kind of cancel each other out, reduce each other, and so I don't have any more x's left. That should be your final answer, and you could quickly double check by foiling or distributing that back through if you'd like. Here's another one. On C, let's make sure it's in order. Check. And now let's look for a GCF. Now this one has 3 terms in it, so we've got to look for a GCF in each term. So what number can evenly divide into 12 and 15 and 27? And let's look for the biggest number we can. Let's also look for the biggest amount of x's we can take out of each term, a greatest common factor with our variables. I ended up getting a 3 and an x cubed. So let's go through and divide each term by a 3 and an x cubed, our GCF. When I do that, 12 divided by 3 is 4, x to the 5th divided by x cubed is x squared, minus 15 divided by 3 is 5, x to the 4th divided by x cubed is just 1x left over, and 27 divided by 3 is 9. The x cubed and the x cubed cancel each other out, so there are no more x's left in that last term. That would be our final answer, factored with a GCF. All right, let's do another one. This one has lots of different variables in it, but let's do the same thing that we've been doing. Try to write it in order if you can. Sometimes it's kind of hard when you have multiple variables. But then let's look for a GCF. What number can you take out of 8 and 16? The biggest number you can divide into both of those equally. And then figure out what's the largest amount of r's you can take out and the largest amount or the common amount of s's you can take out. I ended up getting an 8, an r, and an s squared as my GCF. If I divide each term by an 8 and an r and an s squared, let's see what our leftovers are. In the first term, when I divided by 8, 8 divided by 8 is 1. And you can write the 1 there if you'd like to, but without it there, we all know it means the same thing, right? If I take out an r, I have 4 r's left, so r to the 4th. If I take out s squared, I have no more s's, so my leftover factor would just be a 1r to the 4th. If I take out an 8 and an r and an s squared in my second term, I have left over a positive 2. I have no more r's left, but I have an s cubed left over. We could quickly go through and distribute and make sure that that was the final answer, the correct final answer. It should match what we started with. All right, let's do a few more. Look at this next one. This one is a little bit different. It is written in order, right? But this one, if you notice, has a leading coefficient that's negative. And anytime we have a leading coefficient that's negative, we really want to try to make our leading coefficient and our leftovers positive. So we always like to factor out that negative. So not only am I going to look for a GCF, I'm going to look for a negative GCF. So what's the biggest number I can divide into 4 and 16 and 12? It's a 4, right? But I'm going to actually take out a negative 4. And what's the biggest amount, a greatest common factor, between x cubed, x squared, and x? Well, it looks like a negative 4 and 1x. All right, negative 4 divided by negative 4 should give us a positive 1, right? And x cubed divided by x gives us an x squared. We really like this first term to be positive. It'll help us later on when we have to factor more. Okay, so anytime you see a leading coefficient that's negative, it's always easier to factor out a negative GCF. All right, let's keep going. If I have positive 16 divided by negative 4, I get a negative 4 with a leftover x. A negative 12 divided by a negative 4, 2 negatives give me a positive 3, and no more x's left. So this would be my GCF, negative 4x, and then this would be my leftover factor. All right, look at F. 3 different terms here. It looks like there's a negative coefficient, leading coefficient. So let's see what our GCF here would be if I have a negative 3 and a 6 and a negative 3. I took out a negative 3 and an x because each one of these terms has an x in it. You notice that I can't take out a y from every single term because not every single term has a y. I also can't take out a z because every single term doesn't have a z. I can only take out a negative 3 and an x from each term, the greatest common factor. Leaving my leftovers, when I divide everything by a negative 3 and an x, did you end up getting a y, a negative 2z, and ooh, a positive 1. Now be careful with that one. If you look carefully when you divide, there is still a number here. -3 divided by -3 is a 1, and so it's really important to keep that place there. Most students make a mistake and just write that, which is not correct. Think about if you were to FOIL that out or distribute that out, you'd be missing that last piece. So it's really important that you have that 1 there each time you factor out. Inside your leftover factor is 3 terms. You should have the same amount that you started with. Okay? All right, G and H are a little bit different. Now, we want to factor. We don't typically want to distribute or FOIL. We want to do the opposite of that. So I know a lot of students that look at this first one and want to try to distribute it through. But let's try not to do that because we don't want to FOIL. We actually want to factor. We want to do the opposite of that. What I want you to think of is I want you to look carefully. Do you see this big old term and this big old term that are separated by this plus sign? I know they're kind of funky, but they're still just 2 big terms separated by a plus sign. Now in each of these terms, do you notice anything that's common? Don't they both have an x plus 1 in them? And so if they both have a factor of an x plus 1, that's their common factor. So if I'm factoring out a GCF, if each term has an x plus 1 in it, I can actually factor out that x plus 1. Now, when I factor out the x plus 1 and I divide both terms by it, then what's left over? Well, in my parentheses, I have a leftover x squared and I have this leftover positive 2. So this would be the factored version of my original problem. All right, let's look at H. Again, I have one big old fat term, second big old fat term separated by a plus or minus sign. Don't FOIL or distribute. We want to actually factor. We want to do the opposite. So what do you notice about both of those big old terms? Do they have anything in common? Well, I notice that they both have an x minus 5. This one has an x minus 5 and this one has an x minus 5. So I should be able to factor out the x minus 5. Now this one's kind of tricky. If you factor out the x minus 5, we're dividing both pieces, both terms, by that common factor. When I divide by the x minus 5, in my parentheses, I've got to leave my leftovers. In the first term, the leftover is the x plus 6. Plus, in my second term, the leftover is a 2x plus 5. Do you notice that I put all the leftovers in the same parentheses? This should be your GCF, and these should be all of your leftovers together. So I have this x plus 6 plus the 2x plus 5. Now I can make that second parenthesis look a little bit nicer by combining some like terms. You notice the x and the 2x can really be combined and say 3x. The 6 and the 5 can really be combined into an 11. So my factored version of my original problem is the x plus 5, my GCF, and then my leftovers, the 3x plus 11. That's the factored version of the one up above. Make sure that you're practicing those factors, the greatest common factor, because we're going to be using that technique here in a second for the next video on grouping.